Welcome back to Class Act. It's going to be an exciting day as I work with you and you work with me to look at some important aspects of mathematics. Mathematics to me is the easiest subject any student can ever engage in. Some of you may say, no, you are lying to us. No, I'm not lying to you. I've taught mathematics many times. And my fun part is when students raise up their hands and I say, why is your hand up? And they will tell me, I'm confused. And I say, excellent, excellent. Then they will say, why are you saying excellent? And I say, yes, you are confused because you are thinking through what I'm trying to teach you. So today, when you get confused at any point in time, understand that you are confused because you are thinking. If you were not focusing on me, if you were not paying attention to what I'm teaching, you will never be confused. So, confusion is the greatest part of the learning process in mathematics. But my goal this morning, today, is to ensure that we remove the confusion as much as possible so that we can all engage in mathematics. Math is fun. Let me tell you something very simple before we dive into our topic for today. Understand that when you were in primary 1, kindergarten, your teachers were teaching you in mathematics what is called arithmetic. Arithmetic is the basic of mathematics. That's the foundation of mathematics. That is where your teachers were saying what is 1 plus 1. You were learning how to count 1 plus 1, and then you say it's 2. 2 plus 2, and then you say it's 4. And maybe from there they will say 4 minus 2. That was what? Subtraction. And you give the answer as 2. And then from subtraction, you might have gone on to multiplication, where you say you learn your multiplication tables, 2 times 1, and then you say 2 times 3. You move all the way to 12 times 12, 144, and you were having a nice time. Then all of a sudden, your teacher will begin to show you some different things. Let's look at one thing that teachers probably did when you were at a place like primary 2. Okay? Or maybe sometimes, depending upon how difficult your teacher was and how challenging his instruction was, you probably did it from kindergarten 2 or even primary 1, where you saw something as simple as this. They will do something like 2. Oh, let me go back to my pen. Let me go back to my pen. 2 plus, and then there will be a box there. And then they will say equals to 5. Then the teacher will wait and pause and wait anxiously for you to tell him or her what goes into that box. And then I know most of you have raised up your hand wherever you are, or you are saying, this is too easy. Why are you teaching us this? We are in high school. But just give me a minute of your time. So the moment you saw this, you just say, oh, if you put 3 in there, in the box, you're going to get 5. Excellent. This is your arithmetic, and the teacher was transitioning you, moving you from arithmetic into what we call algebra. Algebra. Now, when you get into algebra, instead of writing the box, you may represent the box with a symbol. That symbol may be A, B, C, but in most cases, we use X. X is our favorite symbol in algebra. So instead of saying 2 plus 3, we'll take away the box, and then you will put 2. Oh, wait a minute. I still have my eraser. Let me go to the pen. We'll say 2 plus x equals to 5. All that we are saying is this. If you add 2 to a certain unknown number, and inside of the box now we are saying x, to a certain unknown number called x, you should get 5. Then you, because it's algebra, you have forgotten about the box that your teacher used to draw, and then you'll be scratching your head and say, oh, this is so difficult. What is x? It is no difficult. X is simply representing the box that you use to have when you were in primary 1 and primary 2. So you see, algebra is not that complicated. It's not that difficult. You've been doing algebra since primary 1, or for some of you even since KG. You were doing algebra. But the teacher never called it algebra. He said arithmetic. Algebra is exploring the world of the unknown. Unknown. And when you find the known, then you call it solving. Solving. For example, in this case, algebraic equation. You are solving an equation. And that equation solution is what we are calling a concept of equation. In algebra, we are saying algebra. It's not difficult at all. So let me quickly look at some basic examples. You see, today we're going to talk about a certain very important concept in mathematics called exponential equations. So we are doing two things. This is like a combo. We are combining two things. We are talking about exponents, we are talking about equations, but if you don't understand equations and you don't understand exponents, you can't do exponential equations. But how can you talk about equations if you have no idea what algebra is? And how can you talk about algebra if you do not understand arithmetic? The beginning of counting, your subtraction, your addition, your multiplication, your division. Now, you move into algebra and you are still going to do your subtraction, you're going to do your addition, you're going to do your multiplication, you're going to do your division. All that is also going to be done in algebra. Now, for you to be very good in algebra, you also have to understand certain important concepts in arithmetic. We'll talk about that briefly before we move on further to equations, and then from equations a little bit about equation, then move on to exponential equations, which means we have to understand what is exponents. I hope today you're going to have a nice time. Even though I can see your faces, I think you are sitting in your seat and saying, so is that algebra? Is that just 2 plus the box? And that box used to be A or B or C or X, and now we've gotten rid of the box, and then we are moving into what we call algebra and not arithmetic. It's as simple as that. I hope you have fun today. Let's break it down. Arithmetic is where we begin. We learn how to count, and then when we learn how to count, we learn how to do additions. When we say 2 plus 3 equals to 5, we're excited. We know we can even use some stones, 2 stones, 3 stones. We pull them together. We count one by one. It gets to 5, and we write 5. And we're super excited. But our teacher begins to say, no, the kids are getting so intelligent. So I'm no longer going to give them 2 plus 3. But I'll tell them 2 plus a certain number equals to 5. But that certain number, I'll put a box and I'll ask them to write in a box. Then you become more intelligent, and your teacher is saying, no way, no more boxes. We've taken away the box. Whatever was hiding behind the box should come out. And when whatever was hiding in the box comes out, then we see A, we see B, we see C, and most of the time we see X, and that gives us our equations. Now, equations is about equity. As we begin, that is about fairness. Whatever you do to the left-hand side, you have to do to the right-hand side. So take note of that. So whatever you do to the left, you have to do to the right, because the left and the right has to be the same. There should be a balance. You cannot add something to the left, you add something to the left, and you say, oh, right, I don't care about you. That's not fair. You've got to be fair when we're dealing with equations. So we are going to begin with a few things in equations, something that you can truly solve. And then once we are able to do that, then we're going to move on quickly to the various things that we are going to talk about today. So let's solve these simple equations. I want you to have fun at home. Number one, let me hit on my pen. We have, okay, let's do this. Okay, 2, okay, let me, I'm having a bit of a challenge with my pen. That should be the pen. Okay, 2 plus x equals to 10. Then I'll say x plus 2 equals to 11. 2 plus x. So, what is x? Can we think of something? In high school, we don't just sit there to figure it out. We need to have a plan. So, what we are looking for is x. And I've already told you, wherever you do to the left, you have to do to the right. We want x to stand by itself. That is when we say that x is alone and we have solved for x. Some number is now going with x. We don't want that number to be there. It's as if I want to tell you some secret, want to whisper into your ears some kind of secret, and your friend is sitting next to you. What am I going to do? I'll tell your friend, can you please excuse us? Excusing us means I'm taking your friend away. And you know, take away means subtraction. So I'm going to take 2 away on our first equation. I'm going to take the 2 away from x. When I take 2 away from x, of course, the plus sign in between has disappeared, right? So I take 2 away from there, I'll get x to stand by itself. So when I do that, okay, so I take 2 away from 2. If I take 2 away from 2, what happens? Can somebody just say it? Even though I won't hear you, say it. I'm going to get x to stand by itself. The plus sign simply disappears because plus x is the same thing as x. But if I take 2 away from the left-hand side of the equation, I have to take 2 away from the right-hand side of the equation, and therefore I take 2 away from 10, and x therefore equals to 8. So x equals to what? 8, and I'm done. Oh, if I want to find out my answer is right, what do? I'm going to put 8 in the place of x. So wherever I find x in the first equation, I'm going to put 8 there. And 2 plus 8 equals to 10. So I'm excited. That's why I say math is easy, because you can always check to make sure that your answer is right. If I'm writing a sentence in an English essay or composition, I will write a sentence well, but my teacher may tell me that no, you did not follow the rule of grammar, even though your spelling is right. You made a mistake here. There should have been some apostrophe. In mathematics, as simple as ABC. I plug in my answer and I know I'm right, and I'm good. I'm excited because I've gotten the right answer. So when I want you to work on the second one on your own, x plus 2 equals to 11. The first thing I want to guide you to do is first ask yourself, I'm looking for x. How do I get x to stand by itself? Like I told you at the beginning, remember I said, I want to tell you a secret. Your friend is standing next to you. I have to excuse your friend. I have to take away your friend. When I take away your friend, you are by yourself, and therefore I can tell you a secret. So who is the friend of x in the second equation? Who is the friend of x? 2. How do I get 2 to be away from there altogether? I have to from that side of the equation. So I need to subtract 2. When I subtract 2 from the left-hand side so that the 2 become 0, it will disappear. Oh, I cannot just do that and forget about the right-hand side. That is why sometimes you hear it say as teachers, wherever you do to the left-hand side, you have to do the same thing to the right-hand side. So let us quickly do that. I take 2 away from the left-hand side. I now have x standing by itself. And since x is standing by itself, I'm free. I have to the left-hand side x. Then since I have to do the same thing to the right, I'm going to take 2 also away from 11, and 11 minus 2, based on my understanding of arithmetic, will give me 9. So x therefore equals to 9. If I want to check to make sure I'm right, all that I need to do, wherever I find x, I'm going to put there 9, and I know 9 plus 2 equals to 11. I know most of you are standing there and say, oh, we are high school students. Why are you doing all this? I just want you to know that mathematics is simple. It follows it's a step-by-step approach. Just get it out of your mind that math is difficult. If you tell yourself math is difficult, math is always going to be difficult. Mathematics is easy, but it goes by rules. If you forget about the rules, then it becomes hard for you. It becomes hard for you. Mathematics is something that you use every day in your life. You may not use geography every day or chemistry every day. Yes, when you're cooking, you use some chemistry. But you see, there are some aspects of science that you may not use every day. But when it comes to mathematics, you use it every day. So don't ever say math is so hard. Just follow the rules. Follow the rules. And once you follow the rules, it's not going to be difficult for you at all. In fact, it's going to be easy, and you are always going to tell yourself, math is easy, math is easy. Math is not that difficult at all. So now we're going to move on. We're going to move on. We have understood equations, I believe, a bit. Now let's follow some things here. Now let's go on to exponential equations. We've talked a bit about equations. Let's move on to exponential equations. Exponential equations is one in which a variable occurs in the exponent. So the question becomes, what is exponent? Because you are talking about exponential equations. You've talked to us about equations. Then what is exponents? Let us look at this. Good. If I have 2, okay, let me go back to my pen again. If I have 2 times 2 times 2, I can write this as, I can write this as 2 to the power of 3, because I have 3 2's. So another way of me writing that, let me raise this side so that, okay. Another way for me to write this is when I say 2 times 2 times 2 equals to 2 to the power of 3. Stay tuned, stay engaged, and stay focused. Instead of using the time symbol, I can also write this as 2, and you put this dot, like a period, in between the dots. And then you put it here, and you put it here. This is also the same thing as times. So when I do this, I can also write this as 2 to the power of 3. We are talking about exponents. Let me quickly do something very simple here. Exponents, we can also actually not just use numbers. If I have a, now we are using symbols, right? If I have a times a times a, remember we said this symbol means times. Okay, this will be a to the power of 3. If I have b times b times b, this is also b to the power of 3. This is also the concept of exponents. Now, let me quickly jump into other rules of exponents. You see, if I have a to the power of 3, a to the power of 3, and I multiply this. Remember, I've already told you that this symbol means multiplication, right? I've already told you that. So I can use times, the regular times that we know, or I can also use the dot in between. So I will choose to use this. A to the power of 2. If I say a to the power of 3 times a to the power of 2, how many a's do I have to begin with? 3 of them. How many a's do I have as the second? 2 of them. So what is the total number of a's that I have? 5. And sometimes some people are tempted to say, oh, since I'm multiplying a by a, I'm going to also multiply 3 by 2. No, you can't do that. And the reason why you can't do that is very simple. There are 3 a's here. So if I expand, I'm having 3 a's on this side. And I multiply a by a. How many a's do I have? Just count. Now we're going back to arithmetic. We're moving from algebra to arithmetic again. Arithmetic never dies. We don't get rid of it. You're always going to use it. So look at what is going on here. You see A. How many a's do we have? You see, I put the times in the middle not to confuse you. But I can also put the times here. Since I'm using times, I have to use times everywhere. So how many a's do I have? That is 5. So this is a to the power of 5. Simple. Do we understand? Okay. Now understand also that we have other properties of exponents. This is the multiplication. When you are multiplying, since the bases are the same, we have a and a, you can simply add the powers at the top. So instead of doing this expansion, imagine if you have a to the power of 100 times a to the power of 200, and we were supposed to write 100, it won't fit here. No way. It will go all the way to Legon, and you will still not end because you have a to the 100. So there's no paper that it can fit on. And that is why it's important for you to know the rules. So if I have a to the power of 100, if I have a to the power of 100, let me do this. Let me do that. Once I know the rules, it becomes easier. Much easier. So this is a to the power of 100. And this is a to the power of 200. I don't have to write it down the way I wrote a to the power of 3 and say a times a times a. I'm not going to die. All that I know is that there's a rule. That if I'm multiplying exponents, I just have to, and the bases are the same, I have a and a. I just have to add the powers. So my answer, the first step would be a to the power of 100 plus 200. And that gives me a to the power of 300. Simple. So I'm using the rules, I'm using the properties of exponents. In this case, I'm doing multiplication and I'm just adding the powers. So these are some of the rules that we need to understand. Now, if you were doing division, it's a different thing. Let me quickly go through that. Quickly. Okay, so that we can get it. But before I even proceed, I want you to know that there are 3 ways of showing that we are multiplying. We can either do a with a dot, as we've already said. I can do a with the dot, as I've already said. We can also do the brackets, and we can do the regular times. So let me quickly go through that. Okay, I can do this. All right, this, I can do that. This also means, when you see this, it also means multiplication. It also means a times a, right? So that is good. Sometimes you don't even have to see everything there. You can also see something like this. Hello. You can, if you see 2 here, 2, and you see this, and b, it also means 2 times b, which gives you 2b. So have that at the back of your minds. Now that we've cleared this and we know different ways that multiplication can be represented, we can do that. It's 2b. There are different ways of seeing multiplication represented. Let's now move on to some other concepts of exponents. So if I have x to the power of 5. X to the power of 5. And I'm dividing by x to the power of 2. You know that at the top I have 5x. So I can expand this. X times x times x times x times x. 5 of them. The bottom is 2x. So it's x times x, right? I'm sure since you are in high school, you have had the opportunity to look at the concept of cancellation. Because you see, there are 5x at the top, there are 2x down. 1x will cancel this x will cancel this x. I'm left with 3 of them. And know that since I'm multiplying, this is not 3x, but rather x to the power of 3. Note that, x to the power of 3. So quickly, let me take this away from here so that I can write that over there for you. So x5 and x2 to the power of 2, we expanded it, we cancelled out, we were left with x to the power of 3. It's as simple as that. Now, then we can do some further deductions. We can do some further conclusions. Look at this carefully. Begin to ask yourself, how did we get the x? We know we expanded it and we cancelled. But as we did with the multiplication, imagine you have x to the power of 200 and x to the power of 100, and you were to expand. You will write and write and write. It won't fit on any paper. Even if it's going to fit, it's going to waste your time. So what do? You have to come up with some rule, some formula, some method. And that method is that when you are dividing exponents of the same base, in this case x, and you are dividing, you are going to subtract the exponent. You subtract the bottom from the top. So when I get this, I should understand that the reason why I got x to the power of 3 is that I simply subtracted. So x to the power of 5 minus 2, and that gave me x equals to 3. So that's another rule. So once you begin to look at this, exponents become a bit easier. And once you can get exponents to make sense, then you are talking about exponential equation and become easy. So far we've done division, we've done multiplication. Also understand that you can have a situation where, let me just show you a quick example of some things that the product, some other things you can do to make life much easier. All right. If I have x, if I simply have x to the power of 2 times 3, it's telling you that x to the power of 2 is repeating itself 3 times. So if it's going to repeat itself 3 times, let's look at what's going to happen here. It's going to be x to the power of 2 times x to the power of 2 times x to the power of 2. If I was to break this down further, it's going to be x times x times x times x times x times x. How many x's do I have? I have 6 of them. So instead of going through all this process and wasting my time, mathematics sometimes help you get some shortcuts. So in this case, all that I need to do is to multiply 2 by 3, and I get x to the power of 6. Note, in this particular case, we are saying x to the power of 2 is repeating itself 3 times. So we simply multiply. We did not add, we multiplied, and that gave us x to the power of 6. Now, one important rule of exponents that you need to get and understand before we move on to exponential equations is that every number or symbol to the power of 0 except 0 itself is always equals to 1. And some of you will say, why? How is that possible? Let me just give you a very quick example. All right. Now, let's look at this. If I have x to the power of 5. X to the power of 5. Let's quickly look at x to the power of 5. If I have x to the power of 5 divided by x to the power of 5, what did we say are the rules when it comes to division? Can anybody try to, even if you are there alone, just shout it to yourself? Huh? Just mention it to yourself. I'll hear you one day. Okay, x to the power of 5. Okay, we said x to the power of 5 and divided by x to the power of 5. The stylus pen. Okay, x to the power of 5 divided by x to the power of 5. I have to write a 5 here. That pen is giving me some trouble, but don't worry, it will be fine. It will be fine. So x to the power of 5 divided by x to the power of 5. Obviously, when you do expand it, since the bottom and the top are the same, x 5 times, you have x 5 times at the bottom, it will cancel each other. So now we've talked about exponents. We begin to see how exponents behave. We've also looked at equations, and now we're going to look at exponential equations. Those are equations where the unknown is in the exponent, and you have to solve for it as you look at the exponent. So for example, I'll give you a quick one, and I'm going to use symbols to begin with. We always have to understand that you can only solve exponential equations when the bases are the same. So I can't have c to the power of x equals to a to the power of b, and I'll ask you to solve. No, the base, the number at the bottom, which is the base, have to be the same. So if I have I have c to the power of x equals to c to the power of y. All that I'm saying is that x equals to y. It's as simple as that. X equals to y. X equals to y for every c, right? From -1, 0 to 1, x will be equals to y. So let me move on to the next step. I really want us to get into exponential equations just quickly. All right, something simple so that you understand. I can say 3 to the power simple 1. If I say 3 to the power of x equals to 9. And I'll ask you, what is x? I know some of you have already given me the answer. You are so excited. Oh, that's easy. That's easy. If that's exponential equation, that's easy. But let me go through the steps. Okay? 3 and 9 are not the same. They are not the same. But we can write 9 as 3 to the power of 2. So I can now rewrite the equation as 3 to the power of x equals to 3 to the power of 2. Because after all, 3 times 3 is 9. 3 to the power of 2 is 9, not 6. I see I've been teaching for many years, and one mistake students make all the time. 3 to the power of 2 is, oh, that is 6. And then when I say 2 to the power of 3, oh, that is 6. No. When you're talking about exponents, understand. When I say 3 to the power of 2, 3 is repeating itself 2 times. If I say 2 to the power of 3, 2 is repeating itself 3 times. Therefore, 2 to the power of 3 is 2 times 2 times 2. 2 times 2 is 4. 4 times 2, obviously, is what? 8. Okay? So therefore, 2 to the power of 3 is never 6. 2 to the power of 3 is 8. 2 times 2 is 4. 4 times 2 is 8. So when you see 3 to the power of 2 and 3 to the power of x in exponential equations, this is so simple. We are solving the equations by looking for the unknown in the exponents, in the numbers at the top. Therefore, my answer is going to be x equals to 2. Why? Because I have 3 as the base here. 3 is here. We have 3 here. 3 is here. 3 is here. And then x equals to 2. When I block the 2 3's, I'm left with x and 2. Therefore, x equals to 2. Simple. I'm sure you get that. It's simple. Sometimes it can get a little bit difficult, but don't worry, we'll get there. We're going to get there. We're going to get to some difficult ones, and I'm sure you'll be able to solve them. Right. Let's get there quickly. Some of you I know are anxious. You are saying to yourself, show me the difficult ones, and I'll do it. So I'm going to show you some of the ones that may be a bit difficult. Let's see. Let's see. Okay. You see on the board you have 2 to the power of x equals to 2 to the power of 4. So x equals to 4. Easy. Simple. Let's move on. And here you see 5 to the power of 2x equals to 5 to the power of 6. Since the bases are the same, all that you are doing is that you are equating, you are simply equating. This is one of the easy ones. You know that the bases are the same. You have 5 and you have 5. So you are free to equate the exponents. Simple. So all that I need to, you can even think that 5 no longer exists. So you're going to have 2x equals to 6. And if 2x equals to 6, what is going to be 6? We know 2 is next to x. It means 2 times x. The opposite of multiplication is division. So for me to get x to stand by itself alone so that I can tell him a secret, as I've already said, I have to divide the left-hand side by 2. Do I stop here and say x equals to 6? I know some of you are saying no. Whatever you do to the left-hand side, you have to do to the right-hand side. What did I do to the left-hand side? I divided the left-hand side by 2, and therefore I have to divide the right-hand side by 2. And I know from arithmetic, even though we're doing algebra now, and I know from arithmetic that 6 divided by 2 equals to 3. Therefore, my answer is x equals to 3. And some of you are saying, is that exponential equations? Is that simple? Okay, let me go back to the question, which was 5 to the power of 2x equals to 5 to the power of 6. 2 we know is constant. X we know is 3. 2x means 2 times 3. And what is 2 times 3? 6. And that is why the right hand side is also 5 to the power of 6. We are getting in there. We are getting in there. Let's quickly move on to other aspects of exponential equations. I know some of you are saying, if this is exponential equation, then it's easy. Yes, it's easy because you understand. It's going to be easy so far as you pay attention. It's going to be so easy. Just pay attention and it's going to be easy. It's not supposed to be that difficult at all. All right. So we've talked about same base, right? Let's move on. All right. Okay. Now, you have to determine that the numbers can be written using the same base. All right? Okay. Now you move on to the next one. I think we've gone through this. We've gone through this. So we've done the rewriting, and we can just so that if you are taking notes, you can take your notes. What we are saying is that determine if the numbers can be written using the same base. If so, you go to step 2, where you write the number using the same base. And then step 3, you use the properties of exponents to simplify the problem. And we've talked about properties of exponents. And then once the bases are the same, write a new equation. Remember when I said 2x equals to 6, I was writing a new equation without the base, and then you finish solving the problem. I always did this for my students when I was teaching mathematics, that if a student is not doing, I'll ask them to set their own questions, solve their own questions, set questions, give it to their friends to solve, and then their friend will set questions and give it to them to solve. If you solve 100 problems of the same mathematical question, when the exams comes, you're going to see a question that you have already solved. Congratulations already, because I know you're going to do well. And thank you to Class Act and Citi TV for a wonderful opportunity of allowing me to interface with our students from across the country and maybe across the world. Who knows who is watching us? Thank you.